Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 1, Part 2. So, Part 1, we derived the distance formula and we looked at a couple of examples. For Part 2, I want to look at how to program our TI-84 calculator so that we can just plug in our 2 points and it will calculate what is the distance between 2 points. Which would be very useful, and it's actually a very simple exercise. So we know that the distance between P and Q is equal to the square root of x2 minus x1 squared plus quantity of y2 minus y1 and quantity squared. Now, if we want to figure out what the distance between these 2 points are, we want to think about it in terms, well, we need to start thinking about it in terms of a programmer now. So when I think about this function or this equation here, I want to think of it as having 4 inputs. I need to know what x2 is, I need to know what x1 is, and y2. I don't know why I put y2 on here 2 times, but that's awkward. There's a, I don't know which is more awkward, that 2 or that 1. Or the fact I thought I hit the eraser and didn't. Alright, now we have our awkwardness out of the way. There we go, there's our y1. So each of these highlighted quantities here is a required input in order for our graphing calculator to tell us what is the distance. So we have 4 inputs and we're going to have a single output. So what we're going to do in order to make a custom program is we need to hit PRGM and we need to create a new one, so enter. Alright, and to create our program, what we want to do is I think I'll just call it dist form, DISTFORM. Now note that your graphing calculator has an 8-character limit for the name. So DISTFORM as the max you can see. Once you get this funny little symbol here, that means you ran out of characters for your name. So let's hit enter. Dist form. Alright. So we need 4 inputs, and to do that we need to prompt the user to plug in those values. So I'm going to click on program. I'm going to go to I/O here. That means input, output. So we want input, hit enter. And now I'm going to hit second and then this green button. When I hit second and this green button right above here says A-lock, that means that I'm going to start clicking on things and it will put in those letters. Alright, we're going to in fact want to delete all those ones though. So we're going to want to do quote. Then how about an X? I guess we need to get out of alpha. So I'm going to get out of the alphabet mode and put a 2. Going to get back in my alpha mode. I want to do the colon, that's where the period is. I'm going to click on the 0 for a space. And then I'm going to end quote. So this will tell us what this will prompt the this will prompt the program user to plug in whatever their x2 is. And so, oops, J. So we now want not the J, but we want the comma. So make sure you exit out. And I'm going to just put this in, how about A? So what happens then is the user will see x2 and they're going to be prompted to plug in a number. That number is going to be stored in memory slot A. Now we need to prompt the user again. In this case, what we need is how about x2? Let's prompt for x2 or x1 now. So let's go ahead and get x1 in here. And I'm going to say put it in B. And then now we need to get the 2 y values. So Here's our y2. Alright, and I'm just going to put this one in C, and we need to do this one more time to get y1. So and here is, so now we got A, B, C, and D. Alright, so now we need to calculate our distance. So I am going to hit enter, make a little white space here, and I'm going to hit second, and I'm going to go right here. There's my square root. Now I want x2 minus x1, that quantity squared. So I'm going to make a parenthesis. Now x2 said is A, so A minus x1, which we said was B. Now we need to end parenthesis, so we've done all this. Has to be squared now, so here's our square. We do plus, parentheses, and then we need y2 minus y1, so that is going to be C minus D and quantity squared. Now we need one more parenthesis, and there we go, we got the square root of x2 minus x1 squared plus y2 minus y1 squared. And let's go ahead and see how this runs. So I'm going to hit second, quit. So second mode is to quit. Now to run this program, we want to hit program. There's our new program. Let's hit enter on it. Enter. Alright. So let's see here. If P is, how about -3, -3. And Q will be, how about 4 and 7. Why not? So let's see here. -3. Enter. Oh, oops, I did that backwards. Oh well. So we'll just plug it in backwards. So y2 in this case will have to be on -3. And then y1 will have to be a 7. It actually doesn't matter which one you call x2 and x1, y2 and y1. As long as if this is x1, then this has to be y1. If this is x2, then this has to be x2. Or y2, I mean. Okay. It doesn't matter if this is x1 or this being x1. Now we hit enter, and voila, there it is. We should verify that now. So we have -3 minus 4 quantity squared plus -3 minus 7 quantity squared, and all that's being square rooted. And there's our distance from P to Q. So -3 minus 7, that is going to be a -7 quantity squared plus, and then -3 minus 7, that's going to be a -10 quantity squared. Alright. So -7 squared is 49. So we have 49. -10 is 100 once it's squared. So that's square root 149. Let's see here. So let's see. We go square root 149. We should get this 12.2 value, and voila. So our program works. Awesome. Well, now you've seen one simple way of customizing your graphing calculator, and in this case it's to put the distance formula on it. Now keep in mind, this won't really help you if you have a teacher like me who insists that the answer needs to have a square root and a bunch of numbers instead of a bunch of decimals. So that is going to depend on your instructor's preference. One thing you could do, so let's go ahead and run our program real quick again. See how this works. So it's a 3, 4, -3, 7. Oh, oops. Well, this is going to give us a different one now. I forgot my negative. But what you could do is if you hit square, so this value here is automatically saved inside a temporary memory slot called answer. Answer stores the previous value the result of the previous calculation. So in this case, the 8.06, etc. That was stored in ANS. And by squaring ANS, you got whatever this was. So that tells you for this set of coordinates right here, the answer was root 65. So you could figure out, well, this has to be root 65. So then that has to be, well, you can break it down, right? So 65 is 5 times, is that 15? No, I think it's 13. Bad at math. 13. Alright. So this is 5 times 13. That doesn't reduce down, so we're stuck with root 65. Now, you could program your calculator to figure out, like we can modify our equation so it gives both the decimal value, and then you can see what it looks like with a with just a 65. In fact, there's probably a way of displaying it with the root 65. Well, we'll think about that, and at the very least, you do have a rudimentary program now. Well, thank you for watching, and if you've been enjoying our content, please subscribe and consider supporting us on Patreon. Thank you for joining the math party, and I will see you next time.